Back, folks, let's take a look at number 26 through 30. 26 tells us that a pad of paper containing 50 sheets weighs 3.2 ounces. When 32 sheets remain, it weighs 2.26 ounces. And they want us to find out how much does it weigh when 2 sheets remain. A quick way to do this would be to use a linear regression on your HP calculator. You would do 3.2, enter 50 sigma plus, 2.26, enter 32 sigma plus, put in the 2 for the sheets, then do push linear regression right, and then predict the y value or the weight. Now let's say you didn't want to do that with linear regression. What would we do? Well, the first thing we want to try to find out is how much each sheet weighs. We can find the difference in the sheets, 50 minus 32, and the difference in those weights, 3.2 minus 2.26. And what that tells us is, how much the missing amount of sheets weighs. From there, we divide the two numbers, and that will tell us how much each sheet weighs. Now, the quick way to answer this question is, well, they want us to find out how much the pad weighs when 2 sheets remains. So, once I have the weight of the individual sheet, multiply that by 48 and take that away from the 3.2 ounces, because we would have lost 48 sheets to only have 2 sheets remaining. A slightly slower way to do this, once you find out how much each sheet weighs, is to multiply by 50, take that away from the 3.2 to find out how much the cardboard part of the pad weighs, the thing holding the sheets. And then from there, add the 2 sheets worth of weight. It's intuitive to want to do a proportion, and it's really good. The challenge is that because the cardboard pad has some amount of weight, there's an offset to each of these numbers. Now we could do this another way with another proportion, where we could do 3.2 over 50 plus x, so to speak, or and then do the same thing with 32 plus x over the under the 2.26. Do a proportion that way and try to solve for x. That would give you the weight of the pad, the unknown, the cardboard portion, which we don't know. Then from there, you could do another one to do 2 sheets, but again, it just takes longer. So I think either the first 2 options work best. All right, number 27. Servers get 12 scoops from a half-gallon of ice cream. What must a caterer spend on half-gallon ice cream tubs to serve 320 people if each person gets 2 scoops, and half a gallon of ice cream costs $5.69? So the important thing to note here is, let's find out how many, or is that whenever we're buying items, we're going to have to round up or sometimes round down depending on the question, because we can't buy fractions of an item. So let's see here how many scoops 320 people are going to need. Well, that's 640 scoops because each gets 2. Now we divide that by 12 to find out how many half gallons we're going to need. Now the reason just about everyone got this question wrong at the UIL meet is because when they got that number, they multiplied by the 5.69. And they forgot that they actually needed to just round up from the decimal portion. So you get the number of tubs, round that up because it's like 0.12 tubs of ice cream extra that you're going to need to use. And then from there you multiply by the 569. Number 28. Marie bikes 3 miles to school in 12 minutes, so her speed would be 3 over 12 miles per minute. And she can walk in 45 minutes, and so her walking speed would be 3 over 45 minutes. On the way to school, her bike broke down. So this is important to note. Sometimes questions get tricky and they say it on the way back home, or sometimes, they'll add another part to the question here. Anyways, on the way to school, her bike broke down. She walked the rest of the way. If the total commute time was 25 minutes, how far from home was she when the bike broke down? This is a popular question, and it can be really tedious to solve, but there's a quick way to set it up. And it involves relating speeds, distances, and times. In this case, they tell us the total distance she travels, 3 miles. Nice. Now she's going to spend some amount of time walking because her bike broke down some distance from home. So the distance that she traveled on bike before the bike broke is going to be X. The remaining distance would be the 3 miles minus X miles. And the total time is 25. Now, if we remember that a time is going to be a quantity divided by its rate of change. In this case, the quantity is distance, and its rate of change is speed, so distance over speed. So we get the 2 times. The time spent biking plus the time spent walking equals 25. Now, thankfully, we don't have to do any tricks with unit conversions because her speed given to us was in minutes. So it's going to be the distance spent biking over the speed she bikes at plus the distance walking divided by the speed walking. Now, you don't have to do all these substitutions on the calculator test. For instance, with enough experience or proficiency, you can jump to this part right here. I would probably still write time biking plus time walking just to make sure I get that part set up right. But a lot of people just start with x over the speed plus 3 minus x over the other speed equals the time, which is what we have here. At this point, you can either do an end solve or you can start doing some algebra. But again, because it's a calculator test, we want to be proficient with our use of calculator, throw it into the solver. The important thing is understanding how the setup of the expression comes to be. Let's go ahead and take a look at 29 as I take you all around this page. They give us the total surface area. They want the diameter, they want the height. They don't give us the diameter, but they tell us that the height is related to the diameter through this expression. So this is okay, this is great. We have 2 unknowns, and we will have 2 equations. One relating the height to diameter, and the other one with a setup for the area, which equals 7690. I'm gonna look over here, and I don't think I wrote out a solution for that. I apologize. No, I got lazy. I'm sorry. So you're just gonna have to listen to my voice incorporeally telling you what to do. So total surface area is gonna be the area of these 2 circles. Pi times the diameter over 2, quantity squared. And what I would do is I would write all of these quantities in terms of the height because they want us to find the height. So in reality, I would say d is going to be h over 0.6, and then the radius, which is the diameter cut in half, that's going to be h over 0.6 divided by 2. So in reality, this is where I'm so sorry to just be blathering symbols and ideas into nothingness without writing, but I'll try here. So it's going to be pi, and there's 2 circles, so there's going to be a 2, and then the radius here, well, that's going to be the diameter cut in half, but the diameter itself is going to be the height divided by 0.6. So 0.6 and the 0.2 would combine into a 1.2 after we rationalize the expression, so to speak. Oh, come on. There we go. And then we would square that. Oops. And that's the 2 areas of the circles there. The next part is, how do we get this lateral surface area? So if we consider a can here, and we were to cut that label and unravel the can, the label would actually be a rectangle. And that rectangle would have the same height as the cylinder, and the width of that rectangle would be the distance around the circle or the circumference. So that would be 2 pi times r. And again, we would write this in terms of h so that when our solver gives us our answer, we just get h right away. Plus 2 pi r, 2 pi r, and r again is going to be h over 0.6 for the diameter, then cut that in half to get it into radius, so 1.2. All of that is going to equal 7690. Throw that into your solver, and then get your answer. All right, last one here. And again, I did not write out the solution for this. I apologize. Having gone over it with y'all in class, I got lazy on the writing portion. So they want us to find out the volume of this cube. Okay, well that's just the side, or x cubed. All right, well let's see here. Oh no, they don't give us the side length. But they do tell us that there's this distance AM, which is going to be to the midpoint of this face. And that's going to equal 25.6. Yeehaw, bring it down. No, bring it down, bring it down. There we go. So the upside to this is we can relate these distances to the side length of the cube. We can solve for the cube length, side length, and then we cube it, and then we have our volume. So the idea here is that we could set up this distance with two Pythagorean theorems. One to get the distance that the segment's going to go this way, and that would be x in one direction plus x in the other direction. And so this would become square root of x squared plus x squared. Pardon that. You know what? I'm going to try copying that. That looks so good. I don't think I'll be able to replicate it. Yeehaw. Control copy. See here. Escape. Oh dear. Where have we gone? Oh no. Maybe I should. Here we go. Oh, you know what? I didn't even copy it properly. No, we'll try it again. Plus x squared. It's just going to take longer than anything, right? So I thank you for your patience. This video is getting a little bit more long-winded than expected. But you know, a good problem deserves a good explanation. So x squared plus x squared. So this plus this, that's 2 of this. So oftentimes we talk about how the diagonal of a square is going to be square root of 2 times x, because it's square root of 2 times square root of x squared. The square on the x squared cancels. Anyway, so that would be the face diagonal here. Now the challenge to this next portion is that for the midpoint, this is only half that side length, x over 2. So then we would do another Pythagorean theorem, this squared plus that squared, and then we equals 2560. Now, one of the ways I want us to try to remember three-dimensional lengths is it's really just an extension of the Pythagorean theorem. So another way we could think of this is x squared plus x squared. And that's because we're going a distance x in each case. So this is like a squared plus b squared. So that's another x squared. And I'm going to try making my 2's like z's. I apologize. And then plus c squared. And in this case, c is not a full distance x again. So that would be x over 2 quantity squared, all of those distances squared, is going to be equal to 25.6 squared. And I apologize that on practice I kept just saying 25.6. Or like when we do law of cosines, I know that it really should be the square part, and I speak as if we do the extra step and square root it and have our answer. So thank you for that patience in understanding. So here, throw that into your solver. When you put this in your solver, if your calculator doesn't have pretty print or textbook print format, make sure that you put the parentheses, because otherwise it will only do x squared divided by 2 instead of x over 2 squared. Alrighty, thank you.